Hello, guys. I am Georgios. We are here for the video 4 of the AI sports referee. I am doing some videos explaining how we can apply AI on high-speed cameras, on the footage of the high-speed cameras, to be precise. So let me recap what we have been doing in the previous 3 videos and what we are going to do today at the video 4. So basically, in the first video, we checked all the setup that we need to use a high-speed camera. You can check video 1 on my channel. The second video, we saw how we can wire up everything, and we fired up the camera, and we had the first footage, and that was recorded at the NVIDIA Jetson Nano. And at the third video, we used the footage, and we showed all the settings that the camera is offering to us, so we can have a perfect video to use for our purpose. Our purpose is for this specific series of videos to see if we can apply AI to find solutions over the volleyball block touch task, where, in my opinion, it's very difficult and it needs a lot of cameras around the field. And of course, there is the human factor that sometimes humans are making mistakes. So basically, we are trying to figure out if we can have a solution that will help human to find solutions easier instead of just going and inspecting video after video after video and finding out what had happened at this specific task. So at this video, we are going to see how we can create a high quality data set. So this data set can be used to train or fine-tune a computer vision model, and eventually using a bigger and bigger data set after shooting a lot of quality videos in the future. Then we will have the perfect data set to train our AI model, and this model will be used later either with computer vision algorithms or a VLM to figure out how we can have solutions over the volleyball block touch case study, this task we are checking. So yeah, let me share the screen and I can guide you on this 4th video step by step what you can do to create a high quality data set. So if you check around, there will be numerous options where you can go and create a data set. Other options are online, like RoboFlow, and other options are open source, and you can use them offline. You can use them in your computer, in your laptop. I'm all these years, I'm really I'm a fan of the open source products. I really like to use them and change them, fork them, change them. And of course, I have been open sourcing a lot of code of my own. So basically today, I'm going to show you the CVAT open source tool that you can use either online or offline. We are going to use this offline, so you can have it on your laptop and you won't be concerned about what your data set, what everyone will be probably use your data set if you just upload something online. So for privacy reasons, it's better that you use some tools offline. And these CVAT guys, have created a really great product. I have been checking it the past days, and it's really easy. With just a few clicks, you can have a really cool data set that you can later save, and then you can use it for your machine learning purposes. So let's see here at the website. So basically, this is a data labeling suite. As you see here, you can try it online, or you can, if you go here and you can go directly to the GitHub page, you can download the folder and you can check the documentation how you can use it. This is the UI that they are offering. They have some examples, and you can go and use on the left side all the tools that you need. We can jump directly to the GitHub page to see what are the instructions of start working with the CVAT algorithm. This is based on a server and a UI that you open at your browser. I think that I have seen that it is working on the Chrome browser, but you can try it also on Firefox and see what's happening. This is the page there on the GitHub. One of the first things that you have to see is that you have to have this Docker engine and Docker Compose and Git installed on your machine. You can go directly and open a fresh terminal, just write the Docker to see if you have installed it. If you don't see all of these settings, then you don't have installed Docker, so we can say later how you can install it. Also, you can check Docker Compose, and if you see also some commands, then you will be absolutely sure that you have installed Docker Compose also. If not, then you have some information from this from their side that sorry, this is okay here. So you can go directly to the installation guide, and you can see here how you can install Docker Compose, and of course go below and install also the CVAT library that you can use on your machine. First of all, I have a Linux machine. So basically, during the previous videos, I have said that I am using a NVIDIA Jetson or in Nano. Unfortunately, this can be used only on 86_64 architecture CPUs, also AMD 64, but the NVIDIA module that I have is an ARM-based, so you cannot have you cannot download and install from the servers of the CVAT servers. You cannot download the image that you want, and you can have it directly and working on your module. So I had to jump to my laptop, where I also have an Ubuntu system by 86_64 with this architecture. So we can jump to my laptop later to show you how you can install all of these commands. But before that, then you just you see here that you have all the information that you need, that how to install Docker. You can have this you can go and execute these commands one by one. I have already done this to my Ubuntu laptop, and they are working pretty great. I didn't have any errors with that. So basically, you see here why, you see the information why you need all of these commands. First of all, to install the Docker official key, and then how do you add the repository to the apt sources. And then, of course, in the end, how you can install Docker Compose, and the Compose plugin, and etc. After doing that, you can check again that Docker and Docker Compose is already installed, and of course JIT. And then you can just JIT clone the repository from the internet, from the GitHub site, and then you just go inside the folder of the CVAT. By the time that you do this command, Docker Compose app, then it starts downloading all the images that you need for your specific system, and it starts. And after that, after downloading everything, it starts the server. You can also do this command, because by doing this, then you are get prompt to create a username and a password, because when you start the service, if you see here, you just go to your browser and you just type localhost 8080, and then you start working like you are pinging and server on the net. But of course, everything runs on your laptop. And when the first time that you are doing that, then you are prompted to use the username and the passwords that you were prompted to create during the setup procedure. So yeah, that was all. You will spend some time, like 20 or 30 minutes to set up, but if you just follow all the commands and all the instructions one by one, you will get absolutely no issues with starting the server on your laptop. Personally, I didn't have any errors during the procedure, and by the time that I opened a new tab on the browser and just typed localhost 8080, then the web service started immediately, and I saw all the UI of the CVAT. Okay, let me stop sharing here, and we will jump directly to my laptop when we will showcase how we can use the CVAT algorithm inside directly inside our laptop. So as we said here, then as we said, okay, yeah, you can see that we have this opened. Okay. When you open the first time that you open the CVAT, you just type localhost 8080, and you just prompt to get to put your username and your password, and then you see like a normal web page, and we are going to showcase how we can use the exported frames of a video that we have shot with our high-speed camera inside this one to create the task that we want. So you just click on the task tab, and you open this one. These tasks are what I have been doing the past days, and getting some experience here with the CVAT platform. You just click plus, creating a new task. You give it a name like ball tracking attempt 5, let's say. You go to the labels. Of course, we are tracking a ball, so basically we can name it ball, and we can use color of this. So if you have more things to track, then you can use more labels below with a different color. So we click continue, and we can upload the frames here. Oh, not the frames. You can upload the frames like a folder, or you can upload a zip file with all the frames inside. And remember that you have to create and you have to order all of this. You have to name all of this like with a very specific name, so you can help the CVAT algorithm to unzip and just bring every frame after another. So remember to name your images like frame underscore 000, then the second one, frame underscore 001, 002, 003, and etc. So you can help the CVAT algorithm to understand the order of all of these images. So I have already a zip from the previous videos. This one is without any annotation that I have done as an experiment in the previous days. So you open it, and you upload it here, and then you have some advanced configurations. You can check the image quality, and you can usually I'm using 90%, and you have also an option to just not use all the frames. You can start from a specific frame, or you can stop at the specific frames. Let's do that for the first let's say 300 frames. And you just in the last one and the last button, you just click submit and open. CVAT is uploading, and it is doing the work that it is required to get everything in order. We wait a little bit. And the task is created. It has already found the first frame of all the frames that is inside the folder. And you can see here that we have a label. We can delete it or not. We can add labels and etc. And the next thing that we can do is just open the job that has been created here. Just click this, and you go directly to the job page when you can start annotating the image. So as we have said, the task is about checking if the ball touched the hands of the players. So in my opinion, we need to track the ball, because inside the field, when you play the game, like the volleyball games, and you have one ball, you don't have two balls or three balls. So if we track to one ball, then we can do a lot of things, like we can have the center of the ball, and we can have a square that is around the ball, tight around the ball, or then we can add some margin on the edges of this square, and we can have like bigger images based on the center of the ball. But the ball will be the center of the region of the interest right now for this specific task, in my opinion. So we can have like a bigger margin, or then we can use all of these images and create a video that it can be used with the VLMs, and have some context and some logic to decide if the ball touched the hands, the arms, and etc. of the opponent. So I believe that by having the ball and the center of the ball and checking about the margins, I think that you can have also less data than having the whole frame, like 900 by 480. If you have only the ball, then you can go to like 100 by 100, and then you can just add some margins. And also all this data will be crucial if you want to process it on a small module like the NVIDIA Jetson Nano. Of course, all of this is something like an experimentation. It's really cool that we can see how we can annotate here one of the things that we are interested in, like the ball here. You can use it for something else, like you could annotate my head here. Or a chair or something else that is moving. So let's go and see how we can work with that. If you see at your keyboard, you have multiple keys. So basically, one of the things that you can do is like move forward with the F key or move backwards with the D key. It's like to close each other. You can go 10 frames with the V key, or you can go backwards with the C key, that is also on the left of the V key. And you can create your annotations based on what do you want, what do you see. And sometimes you just, the ball is like hidden, like here, we see that the ball is hidden. We don't need these frames. We need the hands, we need the ball, but I don't believe that we need the chair there that is covering the ball in the arms. So we can skip those frames. We don't need those frames. So we can go like somewhere here where the ball is like, it starts, you start see the ball and outside of my t-shirt and etc. And of course, you go at the left, you keep, you select track because you don't want the shape, you want to track. And of course, because the ball is like traveling on the specific trajectory, we are not going to use constantly the F key. We are going to use the V keys because the trajectory will be, and you will see how the CVAT algorithm will track the ball and help you do the job faster than just doing the annotation frame by frame by frame by frame. Okay, so we keep we hit the track. We found the boundaries of the ball at the first place. So we create the first annotation of this. And then having this, then you just go forward one frame and you see this, you just, you can go and move the square box where it is. Going forward again, you just move the square box forward, move the square box, and all of these are getting saved in the internal storage of the CVAT here on the service. So you don't have, you can be sure that everything is saved perfectly here. And when we have like the whole ball exposed, let me also do some more things. Or you can go two of them. You can go again here if you think that the ball will go at the predicted trajectory. Usually, sometimes you have to click also Control S or the save here randomly, so you can save all your all the things that you have done, all your process. And of course, after that the ball has left the hands, then you can go like 10 frames because then you have to be, you can be sure that the trajectory will be the same. So you can do this, save the ball, just do some clicks to see that the ball is like perfectly going to the trajectory that you have predicted. Go again. You see here that we don't have to do all of this click by click and frame by frame. You just predict that the ball will go to the trajectory that you want. Sometimes you just have to adjust the square. Everything is saved. And remember that when the ball changes the trajectory or changes direction, then we have to go step by step, because if I go like 10 frames and go back here, then the algorithm will lose its traction where the ball was, and probably we will get some bad frames when we will see the results later. So we'll get back again, and then it's better that you will track this until the ball, for example, here it hits the wall. Sorry, you track it. I'm just using the touchpad. Sorry. It has already here touched the ball. Now we found the frame. So basically now it starts going back. And you can be sure that the algorithm will track the ball really great. And you can have like 2 frames and save here all the procedure, all the process. And then you can go like 10 if you think that the ball will follow the same trajectory. And of course here you can adjust if you think that the ball is like bigger here. And again, and of course remember sometimes you can do here. Of course we have already done something like 160. Okay, so by the moment that the ball like touches the hand, we have to be sure that it's not occluded by any chair or etc. It's not, for example, here I don't want this frame, so we can go here and just say that from now and on it's the ball like disappears, and we can switch outside property and just click it here. We see that we have also left some 100 frames because we said in the beginning that we went from 0 to 300. So we can move forward this where the ball like disappears and we don't want it, and we can have the ball again here that is not occluded by the chair, and we can go again and and track the ball again here to the remaining frames. Start again here, and we are already at the 250 frame. We now have the ball perfect in the specific trajectory, and we can move on. And do the final adjustments here. And now we are going to see, for example, you can go like 5, 10, or etc. Or you can go directly with the V key on the 10th frame from now. And of course, somehow in the end, and we will have like the last frame of the ball. We can have here before it hits the wall. Yeah, I'm using the touchpad instead of a mouse, and sometimes I'm just using the focus of the keyboard. You see here, you can go like back where it hit the wall, and you can go again front. And this was the last frame, the 300 frame. So we had all the traction, and now you can check it directly what you have done, and you can correct the annotations. You can go, for example, back. You can see here that it perfectly found. You can go back. And of course, if you remember, we didn't go frame by frame here, but sometimes hit the V button. And despite that, the CVAT algorithm tracked in the frames in between the click, the 10 frames click. Okay, so you see here that somehow we started tracking here, but then it disappeared. The ball disappeared behind the chair. We don't want that. We go back, more back, and then you see here that we had that frame that we don't like want it, we can go again and like make it disappear. You see here, we don't also want this. We hit back. We don't want this. If you have made a mistake, you just go and click it and make it the property disappear, because probably we clicked here the V button and we didn't think that this will be saved by the algorithm. Of course, I don't want this. You just make it disappear. And somehow here the ball is perfectly what we want, with the hands and the ball and not the chair. So if you go again forward, you see that these annotations have disappeared, and you make it appear again when you want it somewhere here. You just go back. It's really useful to check all your frames, because if you have a good data set, then you will have a perfect machine learning model later to apply computer vision. You go here, you see here back how you can also go back like 10 frames, go back forward frames, and etc. And you can go as far as you want, until here that we don't need these frames to be inside our algorithm. I think it is really good, and we are going to see now what we have created on the with the Python script, to see how the center and the square appears on top of the ball. Right now, you don't have to do anything here. Just click save, and you go back to the tasks page. You go to the actions, and you go to the export task. So basically, you can search. We need the YOLO detection 1.0. It's not a classification, it's not a detection track, it's something different. So we need the detection. It's not bounding boxes or in the bounded box, not a pose estimation, not a segmentation. So you just click detection 1, and of course you also include the images. You don't want to miss that, because you don't want to do a double jump here. You click OK. And the CVAT is just creating all the stuff that we want. When it is ready, a pop-up will appear. And you go to the export dataset task 5. At the options, you just click download. The download goes exactly at the download folder where you have selected from your browser. So we can stop sharing here, and we can go directly to the NVIDIA Jetson Nano, where I have, like in the previous days, I have done the same work, and I have just sent the data set here, because I want to do also the fine-tuning of a YOLO model on device. I don't want to use online services. So I had issues with the because CVAT cannot work directly with the Jetson or in Nano. You have to build the images yourself, and right now it's not my purpose to build images myself. So I just did the work to my laptop, where the Ubuntu, where the CPU architecture is 8664, and right now I'm moving again on the NVIDIA Jetson Nano, where I will show you how the let me share the screen, how the dataset was before, and how the dataset with the annotations are after the procedure that we did a few minutes ago. Oh, okay, let me share the screen here of the Jetson model. Oops. That here, okay. Okay, if you remember, this is the first of the frames. This is the video that we saw earlier. So basically, inside this folder there are all the frames that we have shot with the Basler camera. And let's go now and check what we have received with the after the work that we have done with CVAT. So if you open the folder, inside here, you will get 4 elements. The first element will be an images folder where it has a train folder inside, again with all the frames from 0 to what we have set the CVAT to keep. Like we will not, if we said keep it from 0 to 300, then you will not have like 900 images here. You will just have 300 images here. Of course, you have also the labels. And the labels are in the form of the text files. If you open whatever text file here, you will see the 4 points of the square that will appear on the screen and exactly on the image where the square is. So the algorithm knows where to draw all of these squares. You have a YAML file, nothing special. It's something for the YOLO model. And of course, all this information here about the frames that you are going to the YOLO is going to use, all the images that is going to use. This file is a Python script file that I have created, so we can view now what we have done. So basically, I have created the small file here where it opens the images, it opens the labels, and it reads the images and the labels, and you create a visual with OpenCV also of what you have created. Okay, let's click run to see what we have done here. So after annotating all of this, then you will see that you get the squares. Of course, this one is from my previous experimentation, if you remember here. I didn't want the chair, so this one from previous experimentation where I have included the chair, but I don't think I will keep those frames. And you see, like, this is working perfectly. It have recorded the image, and of course, it has saved all the annotations and the center of the ball. And based on the center, we are going to do an exceptional job later by adding some margin and getting the region of interest that that we want. I don't think I have something else to show you right now. My purpose is now to record some more videos and add all of this and create a good data set, add all of these images and annotations to a specific folder, and then use this with the Ultralytics software libraries so we can train or fine-tune a YOLO model to track our specific ball. In the next videos, we are also going to use some other balls, so the machine learning algorithm will be smarter to understand that this is a ball and not only this specific one. Then we can have like other balls with other colors. So the algorithm is distinguishing between heads, arms, and balls, because of course not all the matches have the same ball. They have different colors and different patterns on top of the ball, and this will be harder for the algorithm to distinguish. I'm pretty excited. I think that the CVAT has done a really great job. It can distinguish and it can save you a lot of work and effort to create the dataset. I'm really impressed. I hope you have the time to check also the CVAT algorithm and create, of course, your own annotations to use at your project. If you like my video, just like, subscribe, and see you later with video 5, how we can fine-tune the YOLO model with the ultralytic software. Bye-bye for now.